Hi, my name is Fabio. I have a project that I love and I want to share it with you. Follow me. In 2010, I found AFR Ltd, company that designed and manufactures underwater rope vehicle. With my team, we designed Keelcrab, the first underwater drone for the care of your hull. We started working on similar products that were available on the market, underwater rod for aquarium tanks. After 3 years of research and development, we present Keelcrab. We don't sold the first version, but only rented to professional clients in order to receive qualitative feedback. Sales started 2 years ago with Pro and Sail 1 models. We manufacture or assemble everything by in-house.
Only after passing the all industry rigorous test, the drone is ready to be shipped.
Thanks to 3D printing, we give full shape of our project. What we think, we can design and mold. Biopooling is the proof of how alive the sea is. Unicellular and multicellular organisms take root on every underwater surface and grow. Unfortunately, on the hulls of boats, cause loss of speed and increased consumption, as just 5 millimeters of vegetation can cause an increase of 20% of fuel consumption. Nowadays, many remedies are offered on the market. Most use toxic paint in order to slow down the proliferation process. Cleaning and painting is a very expensive process. Every year, millions of boat owners spend money and time to clean and paint the hull of their boats. Keelcrab is revolutionary. It solves the problem by acting on the effect and not on the cause. You can use where you want, when you want, and without moving the boat. Definitely avoid the use of toxic paint. The main advantage: reduction of carbon dioxide emission, perfect hull, light and fast than only a clean hull can give, less pollution in respect of our seas, savings in the medium terms. We believe that Keelcrab is a strong Troy horse for technology and innovation.
Its use amazes everyone. It's simple and effective.
We are sure that thanks to Keelcrab, we will convince a large market share to look finally at the world of green solution and their possible integration.
For a cleaner sea, top performance and savings.
Keelcrab is already a reality, it's not a dream. The greater the order, the louder will be the signal of change on the market.
Thanks to crowdfunding, we could move from a manual production in an industrialized production.
The increasing markup allows us the possibility to invest many resources in research and development in order to enhance our products in terms of quality, cleaning capacity and automation. The team is really motivated. We will never stop until every boat will be cleaned by our drones. Keelcrab, the first underwater drone with iPad Android control for cleaning and inspection of your hull. Fast, essential, safe, green and user-friendly. Support us with your pre-order and help us to make this possible.
Hey, I'm David.
And I'm Eric.
And 3 years ago, we came to you, to Kickstarter, and told you about our dream to make a low-cost underwater robot.
We wanted to make underwater exploration accessible to everybody.
A lot has happened in the past 3 years. We've shipped thousands of these robots to 50 countries, every continent. And most importantly, we've built this community of people who are obsessed with pushing the boundaries of what's possible.
So for the last 3 years, we've been working on how to make underwater exploration tools the right way. And what we come up with is something we are extremely excited to announce.
This is the Trident.
At OpenROV, we believe that exploration is not just about gathering data, but also about experiencing new worlds in a new way. We've designed Trident to be extremely fun to fly.
Most ROVs, they move up and down slowly, they go left and right, forward and reverse. Trident is nothing like that. It flies like an airplane. It speeds along, you can bank, you can dive. It's fun to fly. It goes fast when you want it to, but it can slow down and be precise when you have something you want to inspect.
Getting video from underwater has always been a challenge because radio waves don't travel through water. So we've developed a very lightweight neutrally buoyant tether, which communicates the video feed from the ROV up to the surface. That attaches to a wireless buoy, which allows you to control the ROV from any Wi-Fi connected device.
Like a tablet, a laptop, or even a VR device like an Oculus Rift or a Google Cardboard. We wanted an ROV that could go to places that no ROV had been before. So we designed it to be ultra portable, whether you're hiking to high alpine lakes or you're bringing this as carry-on luggage. It goes wherever you go.
Most ROVs are designed to look in specific places where you already know where the target is, but we've realized that a lot of people want to explore with an ROV. We've designed Trident to be extremely hydrodynamic and excellent at going in long, straight lines. This allows you to do lawnmower patterns, being able to broadly explore a place that you've never seen before and find out what's there.
We've seen community members take this model and create 3D visualizations of the seafloor.
Using technologies like photogrammetry and structure from motion, we hope that we can help create maps of the underwater world that will allow us to see it in a completely new light.
I joined this project when it was the initial Kickstarter, and I did it because it was going to be a chance to take this hardware, these robots, and I was going to be able to use my software skills to actually program them and have them do stuff underwater. I've been using that to build a platform now that lets other software geeks like myself contribute and help programmers to find ways to control robots. We've made a plug-in architecture that allows you to add your own components, add new sensors, new technology to an ROV after it's already been developed and out in the field. The OpenROV software, it's bigger than any single ROV. It's opening the door to services and technologies that we're just now scratching the surface of. From mapping to autonomous computer control to imaging reefs and underwater shipwrecks in 3D. We're going to be able to send this data and utilize cloud computing, mesh networking, and all kinds of future technologies to make it available to everybody.
So whether you're a fisherman, a researcher, a recreational boater, or just someone who's curious about what's below the surface, this is the tool for you.
So here we are. We've spent the last 4 years developing underwater robots, and we've never been more excited about the project we have now.
To get to the next level, to bring Trident to life, we need your help. So check out the reward levels, let us know what you think, and together, let's build the future of underwater exploration.
Thank you.
We live on a planet that's 71% water, yet we've only explored 10% of it. We're about to change that. The Fathom 1 is an easy-to-use underwater drone that you control with your smartphone or tablet. We designed it to be the most affordable, most versatile underwater drone ever made. And after 2 full years of prototyping and development, we're finally ready to bring underwater exploration and education to the masses. I'm John.
I'm Matt. And I'm Danny. And we're a team of outdoor enthusiasts, scuba divers, engineers, and travelers that had an idea for an underwater drone that we could take anywhere and use in any environment. I grew up spending summers on Lake Louise in northern Michigan, where a lot of large logging operations took place in the 1800s. Jump forward 200 years, and now every cottage has artifacts and pieces of history on their walls that washed up on the beach. But there are still legends of horse-drawn sleds that fell through the ice and got stuck at the bottom, just waiting to be explored. I thought if I could control an aerial drone from a mobile app to explore from above, why couldn't I do the same thing from underwater? That's when Fathom was born.
Underwater remotely operated vehicles, or ROVs, have been around for a while, but they're mainly large, expensive industrial devices tethered to big ships. And early consumer ROVs, inspired by their big brothers, cost well over $1,000 with no mobile app for piloting. And you need to be a pretty good hacker to put them together.
We knew we wanted an underwater drone that anyone could drop into any body of water and pilot easily using an app on their smart device. And it had to be small and light enough to carry around, meaning a completely new compact design. It had to come fully assembled out of the box, including an onboard 1080p HD camera and built-in high-intensity LED headlights for clear viewing. And it had to be as affordable as lower-cost flying drones with comparable equipment so that every modern-day explorer could have one. We built the Fathom 1 with all of those features, and thanks to custom components and a streamlined design, now you can have it for under $600. That's less than half the price of the closest competition.
Above all, we made the Fathom 1 super easy to use, but that doesn't mean it's limited. This thing is fully modular. Our patent-pending thruster attachment system allows you to easily remove all 3 thrusters for packing, but it also enables customization and upgrades to specialized thrusters, such as these ones with larger fins for stabilization. And we're hoping our backer community will create and share their own ideas for customization. Fathom One also features an integrated rail system that makes adding accessories like action cameras and additional lights or other sensors a breeze. Just slide it on, click it in, and you're ready to go.
We put everything that we have into making underwater exploration and education more accessible to the masses. We built the prototypes, validated our designs, and now ready to go into full-scale manufacturing. All that's left is for you, the Kickstarter community, to show us that you want an underwater drone that's affordable, portable, modular, and completely easy to use right out of the box. Fathom is your chance to go deep and see the world in an entirely new way. The possibilities are truly endless. What can you fathom?
Hi, I'm David Lang.
And I'm Eric Stackpole. We're here to tell you about OpenROV. OpenROV is an open-source, remotely operated vehicle, or ROV, that can be controlled from the surface while relaying live video and other data to the operator as it flies. It weighs 2.5 kilograms and is about the size of a shoebox. That's small enough to test in your bathtub, yet large enough to add payloads like cameras and sensors. The intention of the project is to create an ROV that is low cost and easy enough for anyone to build, but that is still capable of doing relevant scientific research and exploration. OpenROV is propelled by 3 off-the-shelf brushless motors, 2 in the back which allow it to move forward and aft as well as turn, and 1 vertical thruster which allows the neutrally buoyant ROV to change depth. 2 battery packs on the bottom of the ROV provide it with around an hour and a half of runtime, as well as counterweight the thrusters and act as ballast. Between the battery packs is a payload bay, where up to 4 threaded rods spaced 50 millimeters apart can be inserted to accept a wide variety of payloads. Electronics for the ROV are contained in a single acrylic tube. Inside this tube, an onboard computer hosts live video from a webcam and sends commands to an Arduino microcontroller that interfaces with the motor controllers and other hardware on board. Because bulky tethers can significantly impede the agility of an ROV, we've developed a way to communicate 10 base T Ethernet data over a single twisted pair of wire using an off-the-shelf part. The entire interface for the ROV is hosted from the robot itself, so instead of installing software, you just plug the tether into your Ethernet port, log on to the ROV's IP address through Chrome or Firefox, and fly.
OpenROV is completely open source and open hardware, meaning we've published all the design, schematics, and code on the website and invite co-developers to help make it better. It's definitely a maker product at this point, but we think that by being an open hardware project and developing this with the community, that we can create an open source ROV that's capable of serious scientific research. We've come a long way, and we still have a long ways to go. The next step is to get more of these open ROVs out into the wild, into the hands of makers and tinkerers around the world.
So far, we've driven the ROV down to depths of about 20 meters and have operated it in ocean water without encountering failure, but we're still unsure of exactly what it can do. Our goal is to crowdsource testing and development by making these kits available to people who want to help. We believe that ocean exploration shouldn't require a research grant. It should require curiosity. Although OpenROV is still a work in progress, we believe that what we're developing can revolutionize how underwater discoveries are made. We're excited to have you as part of the adventure.
So check out the reward levels and let us know if you have any questions.
Thank you.